it's Miss Sarika, and in this video I will be solving question 1 from the assignment posted today on Google Classroom. Remember, this assignment is due by 4 p.m. this Friday. I'm going to be modeling solving question 1, and hopefully this will help you solve the rest of the problems 2, 3, 4, 5, 6, 7, and 8. The title of the worksheet is Finding Width, Height, and Area of Scale Rectangles, and we are using our new concept of scale factor. If you have no idea what I'm talking about with scale factor, I posted a YouTube before this introducing the concept, and hopefully this will help clarify a couple things. So I actually rewrote question 1 on a separate piece of paper because I like having the more space to work. It's not a requirement for you guys. Okay, so let's get started. I'm going to read the directions. Determine the actual width, height, and area of each scale rectangle. Round the area to the nearest whole number. First things first, what I need to know to solve this problem is that this is not the rectangle. This is a model of this rectangle, and I need to find, given the model, what the actual dimensions of the rectangle are. So, do you guys know what model cars are? They're like little tiny cars, like little race cars that look like the real things. Well, their dimensions are the same as the real things, except a lot smaller, but the relationships are the same. So this rectangle is a lot smaller than this real rectangle we're solving for, but the dimensions are the same, and we can use what's given to solve for this to the real size of the rectangle. So I'm going to label 1.9 centimeters as the width, and 4.5 centimeters is the height. I'm not going to worry about area right now. All I'm going to solve for is the dimensions of this rectangle, the rectangle we're solving for. This really large rectangle that we have to change from the model to the actual size. So again, the rectangle given is just a model of this really large rectangle we need to solve for. We are given a very important proportion. 1 centimeter is equal to 9 feet. So that means that the model, 1 centimeter, is the same thing as 9 feet of the really large rectangle we're solving for. So I can use this proportion to solve for the width in feet of our large rectangle. Well, I'm given that the model is 1.9 centimeters width. So this is the width. It's 1.9 centimeters width. And that's equal the centimeters and centimeters, and then feet and feet. I don't know what the relationship to the feet are, but I know that if 1 centimeter is the same thing as 9 feet. Therefore, 1.9 centimeters is the same thing as x feet. And I just need to solve for what x feet is. So what the width is in feet. Well, to go from 1 centimeter to 1.9 centimeters, I'm multiplying by something. 1 times what equals 1.9 centimeters? Well, 1 times 1.9. 1 times 1.9 is 1.9 centimeters. And if I multiply by 1.9 in the numerator, I must do it to the denominator. So I multiply by 1.9. 1 times 1.9 is 1.9 centimeters. 9 feet times 1.9, well, I'm going to grab a calculator. And again, you guys are more than welcome to use calculators to solve. 9 times 1.9 equals 17. X is 17 and 1/10 feet. 1.9 centimeters, 1 centimeter, 9 feet. Therefore, 1 centimeter, the relationship stays the same. 1 to 9. It's 1 to 9. So if my width of my model is 1.9 centimeters, then my width of my really large rectangle is 17.1 feet. So I found the width of my new really large rectangle. Now I want to find the height of my really large rectangle, and I'm given my model to help me solve. Again, I'm going to use the proportion given. 1 centimeter is equal to 9 feet. My height given on my model is 4.5 centimeters. Therefore, my feet is x feet. So to go from 1 centimeter to 4.5 centimeters, I'm multiplying, not adding. So 1 times what equals 4.5? 1 times 4.5. And if I multiply by 4.5 in the numerator, I have to multiply by 4.5 in the denominator. Well, 1 times 4.5 is 4.5 centimeters. 9 times 4.5, I'm going to grab my calculator. 9 times 4.5 equals 40 and 5/10. So 1 centimeter. So this proportion, 1 centimeter for every 9 feet, is the same thing as 4.5 centimeters for every 40.5 feet. The relationship stays the same. So that means my new height is 40 and 5/10, 40.5. Okay, so now I have my new width and my new height. And again, this is the width and the height of the really large rectangle in feet. The 1.9 centimeter width and the 4.5 centimeter height was the width and height of the small little model. And I can find the area. We know that to find the area of a rectangle, it's length times width. And units are always squared for area. So it's length times width, and feet, so I'm going to plug in 40 and 5/10 for length, 40.5 feet, times width, which is 17.1 feet. And I will get, I'm going to grab my calculator, 40.5 times 17.1 equals 692 and 55 feet squared. Well, the directions said that I need to round to the nearest whole number. The 5 after the decimal tells me to round up. So to the nearest whole number, the area of my really large rectangle in feet is 693 feet squared. Okay, again, we use scale factor a lot when we're building models. So architects use scale factors to get the dimensions of a house, and they will use the model to create the house. And the model is a lot smaller usually. I want us to think of different models in our house. Maybe we have a toy car that's a model of a really large car. And please comment below with any models that you see in your house. Any comment, a question, or something you've learned will be participation credit for the week. Okay, see you later.